Okay, everybody, let's take a look at review 2. So this information is still on the test as well, so I think some of this is going to be easy for you. So let's take a look at number 1. It says sketch. Draw a sketch of a function and then a non-function. So we know that it's got to pass that vertical line test. So I'm just going to draw any old line. There's a function because we know that this will pass that vertical line test. You don't have any 2 points that are going to be the same. Now, if I drew something like this, that is not a function. That's not, because you have an x value here that has 2 different y values, so that's not a function. Okay, so I just drew a picture. Okay, all right, that should be really easy. Number 2, graph y equals negative half x plus 4. I start at 4 for the y-intercept. 1, 2, 3, 4. And then after I go to 4, then I apply my slope, which is down 1 over 2, down 1 over 2, so forth and so on. And there it is. Okay, now the slope, negative 1/2. The y-intercept is here at the point 0, 4, and the x-intercept is all the way over here at 8. It's at 8, 0. Okay, that's the x-intercept, the y-intercept, and the x-intercept. Okay. Number 3, rewrite into slope-intercept form. So I want it to look like y equals mx plus b. So I'll solve. Okay, so my 3x minus 4y equals 12. So I need to solve for y. So I'll go minus 3x. Minus 3x, I'll have a negative 4y equals a negative 3x plus 12. Okay, all right. Then I still need to solve for y. So divide by negative 4, everything. I'll have y equals a positive 3/4 x minus 3. Okay, then I want to graph this line. Okay, so there it is. And I want to graph this line, so I'm going to start at negative 3, y-axis, and I'm going to go up 3 over 4, up 3 over 4, and I'm going to connect the dots, and there's my line. Now, what's the slope? Well, the slope is the positive 3/4. We know the slope is that number. The y-intercept is here at 0, negative 3, and the x-intercept is here at 4, 0. Okay, y-intercept, x-intercept. Okay, all right, pretty easy. Okay, turn the page to number 4. Okay, find the first 5 terms of this arithmetic sequence. All right, so I'm going to put in 1. A1 is 3 minus 2 times a 1 minus 1, which is going to be 3. So A1 is 3. Then I'll put in 2. A2 is, I'll go 3 minus 2 times 2 minus 1, because I'm just putting in the numbers in for putting in 1, 2, 3, 4, and 5 in for n. Okay, so A2, let's see, that's going to be, I believe that's a 1, because 3, that's 1. 3 minus 2 is 1, so A1 is 1. A3, I'll put in 3, and I'll go 3 times 2 times 3 minus 1, which is going to be a 2. I'll go 3 minus 4 is negative 1. I see a pattern. I'm starting to see a pattern, okay? So my first term is 3. 1, 2, 3. And then I'll have a 1. And I'll have a negative 1. I can see the pattern. Then I'll have a... So my terms, the first 5 terms have to be, to do this one, they have to be the set 3, 1, I see a pattern negative 1, going down by 2, negative 2, and then negative 5 are my first terms, and so it just keeps going down and down. Okay, now find the equation of this line in the slope-intercept form. So let's change it. I really need it to be y equals mx plus b. So let's change it to y and x. So change this into y and x. So I'll go y equals 3 minus 2 times x minus 1. So I change it into slope-intercept form. I need to change it into y equals mx plus b. I did that. I made the a of n be y, and I let the n be x, and I'm just going to solve it. Y equals 3 negative 2x, because I'm distributing, plus 2. I'll put those together, and I'll put y equals a negative 2x plus 5. That is in slope-intercept form. Okay. 5, almost done. Frankie writes his house 10 miles, is 10 miles from his house. He travels 4 miles in 20 minutes. I meet Sally at the park. He talks to her for 15 minutes. And then starts his journey. After an additional 45 minutes, he arrives at Johnny's house. Okay, so let's see what we have. We have time, and we have distance. All right? Now, he's going to be 10 miles away. So let's go here. Got to have 10 up here for sure. 5. Time, it seems like it's in terms of minutes. We go 20 minutes, 15 minutes. So let's go maybe 10 minutes, 20, 30, 40, 50, 60 minutes, 70 minutes. Okay, so forth and so on. Okay, so let's see. Frankie's going to start 10 miles from his house. Okay, so he's right there, 10 miles from his house. All right, got it, 10. And then he's going to travel 4 miles. He's going to travel 4 miles in 20 minutes. Okay, so he's going to travel 4. So that means he's gone 4 miles. So he's 6 miles away from his house, right, in 20 minutes. So right about here would be he's gone 4 miles, so he's 6 miles from his house. Okay, so he just traveled there. Boom. And then he's at Sally's house, or at the park. He's at the park, and he talks to her for 15 minutes. Okay, so that's going to be 15 minutes. There's 10, 15 minutes. So he doesn't go any distance, but time travels. So time moves, but its distance doesn't, right? And then from there, he starts back. So an additional 45 minutes to arrive at his house. Okay, so 45 minutes. So we've got then, let's see, there is my 5, 15, 25, 35, 45. So he's going to gradually make his way back to his house. Okay, there we go. Now, independent, dependent variables. Okay, so the independent variable, independent, is time. He can control his time in terms of minutes. And then his dependent variable, it's got to be distance. And that's in terms of miles. Oh, a little bit of whiteout. That's right. I can fix that up later. Oh, here's my whiteout. Didn't mean that. Get that scribble in there. Get rid of that. And then finally, we want domain and range. So domain is from 0 to 80 minutes. So the dependent variable is, so as far as domain, which is always the x, it's from 0 time to 80 minutes. And his range, which is going to be in terms of miles, is 0 to 10 miles. Okay, that's all I have. Pretty easy. If you have any questions, come see me. Make sure you have this in your notes.